chapter 7, day 5. So again, I just want to encourage you guys to pause the video and try these things for yourself, and don't go straight to just watching me do it. You'll never get better at these proofs, and it can be a bit of a tricky proposition. So the warm-up is parallelogram 7. Again, we want to keep in mind a couple of things here. We want to we have our proof notes as far as starting with the given, ending with the proof. Given might be evidence later, keeping your shapes and knowing your shapes and definitions of those shapes. Parallel lines as angles and angles as parallel lines often, and triangle congruence and CP/CTC go together. And again, I would say be filling out the shape definition. We're going to be using this for sure today, and as well as these kind of tricks for these are kind of like evidence essentially of why we say we know something is true. So anyway, we'll go ahead and jump into this one. Again, hopefully you're pausing it and trying it for yourself, but I'm going to start with the given. I'm trying to prove that the quadrilateral is a parallelogram, it looks like. So, all right. So I will start with that as a given. So I know angle 1 is the same as angle D because it's given. And I know that angle 1 is the same as angle B because that is given. I think I can say AD is parallel to BC. I kind of regret actually some of the order that I did this in, because like I said, I kind of like to have this tell a story. So if angle 1 and angle D are the same, then I think I can say that this line and this line are parallel because of alternate interior angles. So I'll actually say that first. I'll say AB and CD are parallel because if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Now I'll go with the next given, and 1 and B, those are going to be corresponding angles, right? So I can say that these lines AD and BC are parallel because of corresponding angles. And then finally, hey, this thing must be a parallelogram because that's the definition of a parallelogram, that all of the opposite sides are parallel. And that worked. And again, I could have changed the order here of 2 and 3. It's just one of those things where I talked about these angles, so I want to talk about the lines that go with it, and I talked about these angles, so I want to talk about the lines that go with it. I could have just given all the given and then everything that are proved, but I like to have my proofs tell a story if I can and go in a logical sequential order. So again, you'll notice hopefully that we started with the given and with the prove. The given became evidence later. I don't know if we really saw that in this one. Yeah, that wasn't really, not really in that one. But knowing the shapes was important because I knew if I wanted to prove that was a parallelogram, that I had to prove the opposite sides are parallel. Definitely use the parallel angles and the parallel lines and the angles that went with that. All right, so the next thing we have is a couple of proofs. And again, I would love it if you guys would pause this and try this for yourself. I've given you a little bit of a scaffold here, and I just want you to see how much of this you can fill in on your own. And PQRS is a rhombus, and I know that because it is given. And then I don't know if you guys know what the definition of a rhombus is, and hopefully you know that we need to know our shapes and those definitions, and that we're filling in this one here, and that we have a rhombus right there. So I think we should fill in what a rhombus is. But a rhombus basically just means all the sides have the same length. So I know PQ is the same as QR, is the same as RS, is the same as PS. That's actually the definition of a rhombus. Next, it says this is given. Draw a diagonal PR. So it's having us draw this here. And hey, look at that. I turned them into triangles. And we can do that because an auxiliary line drawn to connect opposite vertices. So we can just sort of draw a line if we want and draw an auxiliary line. So at this point, I think what would be a good idea to say is I'm starting to look at triangles here. So what if I say PR is congruent to PR? And I say that, hopefully we know that is because of reflexive. That's the reflexive property, right? And now I can say that triangle, I didn't fill all of this in, so hopefully you guys got that. Anyways, triangle SPR is congruent to triangle QRP, and we'll say that is because of side, side, side congruence. And hey, anytime I'm using triangle congruence, I'm probably going to come back with CPCTC. So let's see if that's the case here. So I have these triangle congruents, and we're saying, hey, this angle SRP is congruent to this angle QPR, and we're saying that SPR is congruent to PRQ. And yeah, I think I'm going to say that's true because of CPCTC. And now I can end this up by saying I want to prove these opposite sides are parallel, so I guess I'll say these opposite sides are parallel. I'll say PQ is parallel to SR, and I will say that PS is parallel to QR, and I will say that I think because I've proven alternate interior angles, right? And again, using this logic right here, I have these angle relationships, and now I'm going to use those angle relationships to prove parallel sides. So if alternate interior angles are congruent, then lines are parallel. And there we go. I can prove that these are parallel. I'll go ahead and pause for a second and set up the next proof. The next proof, and again, it's sort of set up and partially filled in, and hopefully you'll pause the video and film as much as this as you can. Especially, again, really trying to focus on some of these hints, because I think it's really impressive how much of these proofs you can fill in if you have these things in mind. Alright, so hopefully you try that, and here's what I think. So I'll start with PQRS as a rhombus. I don't actually need to say all the other stuff, I don't think. That's just sort of, those are diagonals, they cross a T. I guess maybe I should, because I want to prove that they're bisectors, but even still, I will say given, I'm running out of room here, and maybe I want to write the whole thing, so I'll just put that to fill in the whole thing. So because of that, I know that PQ is congruent to RS. As a matter of fact, I know all the sides are the same, but I only need these two apparently, so I will say definition of a rhombus. Next, I can say PQ is parallel to RS. Now, you might remember, we actually proved this in the last proof, so we can use it now. And I want you to be really careful with this. When we're filling in these sheets here, the definition of a rhombus is that all the sides are equal, not that the opposite sides are parallel. We know that the opposite sides of a rhombus are parallel because we proved it, but that does not make it the definition of a rhombus. So you need to be real careful here on what your evidence is. Definition of a rhombus versus, the opposite sides of a rhombus are parallel. All right, so because we have these, we can now come and say that RPQ, this angle, is congruent to PRS, this angle, and we can say that PQS is parallel to RSQ. And we can say all that because if lines are parallel, which they are, then alternate interior angles are congruent. And again, I know I keep harping on these, but I think it's really important. There you see we have parallel lines, so we use those angle relationships. If we have parallel lines, there's a decent chance we're going to look at angles. So just be real clear on that. Next, we can say that I know that this little triangle right here, PQT, this little upper triangle, is congruent to RST, the little lower triangle. And I know that's true because of angle side angle congruence. And again, hey, if I'm proving congruence here, there's probably a reason I'm proving it, probably because I want to use CP/CTC next. So I can say that ST, this one right here, is congruent to QT, and I can say that PT is congruent to RT because that is CP/CTC. I know that these triangles are congruent, so the parts must also be congruent. And then finally, I can go back and say RP is the bisector of QS, and I can say QS is the bisector of RP. Look at this. QS cut these into halves. These halves are the same. And then RP cut this in half, and these two halves are the same. And how can I say that? I can say that because that's the definition of a bisector. And again, on this one, you want to be real careful here. So I'm going to refer you back to these notes. When we're talking about a bisector, again, you can bisect an angle and make two smaller angles that are half the size, or I can bisect the side and make two sides that are half the size. So again, if I'm looking here, I want to, I guess I'm kind of done with this proof, but I can bisect an angle and get two half angles. That's not what happened here. What happened here is I bisected this side, and I said that their halves are the same, and I bisected this side, and I said that these halves are the same. So that's what happened there. So again, proofs are tricky, no doubt, but I think especially if we're really focusing on these notes, it can really help us our way through it. So again, if you just sort of go through, I started with the given, I ended with what I was trying to prove. The evidence that they gave me, the given became evidence later. I needed the definition of a shape, helped me right there, right? I ended up having angle relationships to prove parallel lines. And I actually had parallel lines to prove an angle relationship. That's what I should say. Parallel lines prove an angle relationship. I had triangle congruence, and that I was able to use CP/CTC. So you can see a lot of these tricks really do come just from knowing what this sheet means. If you understand this sheet, proofs are going to be a lot easier. If you don't understand the sheet, I think proofs are going to be tricky. So hopefully that's not the case.